All right, let's move on. Yeah, we've seen how this works, and again, I think this works like a charm for what we do, and I'm pretty sure in other domains for other topics it works basically the same. With regard to the papers that I have here, we can, I mentioned the plugins. And if you want to interact from ChatGPT with the PDF, not using Clarity or something else, you need what is called a plugin, right? So I need to open here new chat, and with the Pro version you see down here plugins, right? So now we have ChatGPT plus plugins. You can always only use one. You cannot click like advanced plugin, Bing and DALL-E at the same time. So it's just like exclusive options. It says no plugins enabled. Here I have just a few installed. I'm not using them. Here Wolfram, that's for advanced math. AI PDF is one that lets me interact with a PDF. So for example, that was the first example that I had, the PDF, first chapter of my recent book. And when I here say provide a summary with 7 bullet points of this PDF, this link. And if this works well, so from my experience, it not always works immediately, but you see now it says something like using AI PDF. So what has been happening? It notices here, there is a link. The link is pointing to a PDF. PDF is nothing that ChatGPT does on its own, so it refers to the plugin, right? And now we can also interact here with I don't know where the red is now coming from. Network error. I hope that's not like. But I don't know where the red highlighting is coming from. But basically, we have been at the end, right? 7 bullet points.
Connected to the Wi-Fi here. It seems that you're connected to your phone. Would it go?
No. I'm in the. This is just showing me my hotspot, but I'm in there, right? So that's the way where I would say, well, I'm here in ChatGPT, I have a couple of research papers, and I want to dive into such a paper. So let me regenerate that, because there was sometimes, it doesn't have to be your Wi-Fi or your machine, sometimes also OpenAI connection simply happens, right? Like with any other one. And I think one of their major problems currently is to scale the infrastructure to simply answer all the calls that they get. So this is the simple thing. In here you find a couple of research papers that are relevant for what we are going to cover later on. Let's say we go here with the GAN part, general adversarial. Or maybe let's go with the attention is all you need one. I cannot copy this here. Where is it? So I can mark this, right? And could now do what I have been showing before, right? Go to this paper. Attention is all you need. Now I go to Clarity, and then could go that way. Or now that I have the plugin, this should work here as well. Yeah. Provide the 5 key insights, or whatever, key takeaways. Takeaways is something that I write quite often of this paper in bullet point form. For example, this is now the same thing. Basically, it sees, there is a link. What is this link all about? It's about a PDF. And then it starts using the plugin. Of course, I could go. Here you see here we finished processing the whole document with the PDF search plugin. What else would you like to know? You could now start interacting with this particular paper here. And a little bit more flexibility than with Clarity. With Clarity, you are more or less, with the first use case that I've shown, constrained to the PDF. Here, of course, with ChatGPT, you can get answers around that, or add here, add context, do X, Y, that, right? And you see this research paper, Introduction Motivation, Limitations of Recurrent Models, Transformer Architecture, Scaled Dot Product, Advantages of Self-Attention. So it always pays off when you write prompts. It feels like light years away from the so-called prompt engineers that seem to make 500,000 per year in the meantime. I don't know if anybody is paying 500,000 for somebody who writes prompts, but this is what you read on Twitter. And but to make it as specific as possible is always good guideline without doing some fancy stuff. So research, right? Now you can interact with the paper. You can use different extensions or different applications, such as Perplexity for different contexts. Let's say we have this now. This alone, I mean, acquiring knowledge, going through information with limited time always has been one of the major constraints, I would say, right? People try to do speed reading, photo reading, whatever, right? But this is, of course, a gazillion times faster than a single human being could ever be. So what else can we have? And for me, what is now coming is also one of the absolute fantastic things, namely generating questions, exam questions, multiple choice questions, coding exercises, whatever. This is something I'm honest, hated to do. Our program over the years was always really short and thin on questions, tutorial stuff, etc. because simply I don't like to do it. I simply don't like to do it. It's tedious, and everybody who has ever come up with proper exams knows that it's not simple, right? It's not simple, right? I recall my times at university. I've just created one exam, and my professor always called me, "Come over. This is not solvable." I said, "Yeah, here it's solvable. I checked it." "Oh yeah, you're right." And my professor couldn't solve the question that I had. The former was microeconomics, right? Back then, so it's difficult. I recall this hours on end. You need to make sure that the student really understands it. That there are not like 10 options. That, right? Anyways, I didn't like it up until today. This is now one of my favorite things, to generate questions, exams, and stuff for our students in the CPF program, right? Also cheat sheets, for example. I haven't included one of these, but if you copy this here, this is what I like as a starting point always. So first the cheat sheet with the facts, then yes, no questions, then multiple choice, then coding, right? And if you go through all of that, I'm pretty sure you acquire the skills and not think, I've heard of data frames and what I can do, what the methods are now. I think after you go through all the questions, etc., you should be pretty good. So let's start a new thread. And in this context, we could now say, well, I don't need browsing, I don't need data analysis, no plugins, right? I could simply go with the default here as one example. And when you read the text, generate 10 yes, no questions about NumPy and the array objects, make sure that the answers are half yes, half no. So I've had many cases where I get for 30 answers, 30 times yes, right? So then the student would say, well, it's 30 times, this can't be the case, and goes back and then answers no for stuff which is obviously correct, but therefore here I say half yes.
Who did that intentionally?
Sorry?
He had every question on his test was true except one.
Yeah.
And he didn't tell students.
The outlier, yeah. I wouldn't tell as well, but for me, right, it's not about getting grades or something for the people, but there must be some, let's say, unpredictable component in it. So it creates a question. Question 7, can ND array objects be created from Python lists using the NumPy array function? If you have never heard, I think we have a few here today who haven't done that much Python. This might not be obvious, but I hope if people have followed the hours on end of instruction and have read the books, they know yes, right? And the explanation here added in that's what I meant with regard to be as specific as possible, provide the answers, possibly with explanations after the questions, right? And this was number 7 here. You can create an ND from using tuple list or tuple using the array function, right? and so forth and so forth. Again, that's for me is like sliced bread, because you can provide a ton of exposure, and this is obviously not constrained to programming, right? This can be finance about, I don't know, the capital asset pricing model. Ask questions about the major assumptions of the CAPM, or whatever, I don't know, right? This is your imagination is the limit. For yourself, you can do it for yourself. If you have paper assignments before your exam, right, then you can, ask questions to the paper and get questions generated about the paper, right, to test yourself. The second one, multiple choice questions, a classic, right? 4 MCQs with 4 options each. Again, I try to be as specific as possible, but not writing Tolstoy-like prompts, right? Make sure that the answering options are as clear as possible and that only one option is correct. I've had a couple of instances where 2 were correct, 3, or it wasn't clear, you know. So the more specific, the better. Provide the answers possibly with explanations after the grade. Again, here the first one, which of the following is not a valid way to create a pandas data frame? So that's really, right? I would say almost creative, right? Which is not, and then not here in capital letters using a list of strings, explanation, while blah, 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 blah. Fantastic, I think, right? You should go through it, you should understand it, what you're doing here, because it's not always correct. But in a programming context, I have the feeling that JetGPT in the meantime is pretty good. Last but not least, coding exercises. Generate 5 Python coding exercises about Python list objects. That's something that I really like to generate for the major topics that we cover in the program these days with JetGPT, right? The exercises shall build on each other, right? So that they are not too simple. If you have like simple coding stuff, 10 different ones, that's usually too simple. So I always like to have it step by step so that you learn something along the way and the code will build on top of each other. Provide sample code solutions, potentially with comments, explanations after the question, same thing here, or we are getting through it, right? List creation, list append, list insertion, etc. pp. I think point is there, and if you haven't used it, I can only recommend that you spend a few hours and explore what is possible in this context, right? So the first 2 points. Then coding quant finance models, I have added to the Git GPT programming, and here I have not created something new. I've rather chosen something which is almost a half-year old, where I've given a talk, a rather short talk at our local Python group, which is not finance dedicated. So our state, our city is so small that you need to be a little bit broader, right? In London and New York, we have the more focused ones. And here, back then, this was like, I was like giving this talk and I was with big eyes and open mouth, right? What it all can. So which role does the heat equation play in the Black-Scholes-Merton option pricing model? Heat equation from physics, and those who have studied that stuff, they know that's kind of like the basic, the basic solution approach of the Black-Scholes-Merton model. In particular, going back here to Merton is based on a solution for the heat equation, right? You reduce the original equation to the heat equation, then you solve the heat equation, and then you arrive at the solution. And here it is explained. So there's no, what shall I say, neither Python code nor anything else. Then I prompted it, provide the mathematical details, right? Then you get here the stochastic differential, the partial differential equation, the PDE, for the model with the single substitutions, and here substituting what I was saying before with 5 words, substituting these variables in the Black-Scholes-Merton equation and simplifying, we get the heat equation, right? And this is a well-known equation from physics and can be solved easily. Standard mathematical approach, reduce something that you have to something that is well known and where solutions have been devised, then solve it that way and maybe transform the stuff back. European option pricing, now about Python coding, right? You provide here a couple of parameters and it provides the Python code. And I must say back then when I did that, all the Python code that JetGPT was spitting out was correct and executable out of the box. There's no guarantee that that's always the case, but for what I've been doing, maybe I was lucky with the prompts or I don't know, it worked. And I wanted to, and the talk title was about BART as well, and I wanted to do European option pricing with BART, which I don't know if we now have access, but when I did this, I needed to VPN to the US in order to get access to BART, because I think it's still not available in Europe. And afterwards, I wasn't too disappointed that that's the case, because the code that BART was spitting out was wrong from A to Z, didn't execute, and after some corrections, it didn't work. Maybe, and this is really qualifier now, maybe it's gotten much, much better, but back in the days, meaning it almost feels like ages, half a year back, it didn't work, and this is what you find here as well. So none of the code options, and I've asked it for a couple, and to improve, and to do here, to do there. And it was not only about the financial side, it came up with math.norm CDF, that's stuff that is not there. Here it's a conceptual error, right? It's about a European put option, right? But it did the call option side, so it was financial, it was programming, maybe not understanding it correctly. And of course here JetGPT, this was the only BART example that I had in the JetGPT for somebody like me who doesn't know any Rust, but Rust at the same meetup we had somebody speaking about Rust, therefore I included Rust. I don't know anything about Rust, but I know the Python side and I can formulate here a prompt, and I got my Rust code here in the same way. So like a translator, if you like. Monte Carlo simulation, standard stuff, even with here the visualization, which I think I wasn't asking for. No. I was asking for the visual. Sometimes it simply does visualization when you are not asking for. Here, European option valuation, American option valuation, even did like, I must say, a pretty efficient and well working Longstaff-Schwartz algorithm here. I mentioned this before. This was one of the first algorithms I worked on with Python when I started using Python for finance. This was a time where there wasn't even NumPy around, just to give you a feel for that. So there was numeric and numarray, so the precursors of NumPy. But it does a great job here. It's a nice implementation. It works. It gives the here result with the parametrization. So this result doesn't need to be exactly the same that is reported in there. Even the one that is reported in the paper is not the absolutely theoretically correct one, right? But it does a great job, and you could, I don't know, increase, for example, the number of monomials that is used for the regression here in order to get better results. So excellently described. Also binomial option pricing using vectorization, all pretty similar to what you will find in my books, which are not written after 2022 when it came out, so many years before that. An example about this, more or less with the same, this is what I was saying, with the same names for the parameters. Basically, this could have been written by myself. So when I have a look at this, I hardly find anything where I would say I would name a variable differently or whatnot, right? Go to the first edition, for example, of Python for Finance 2014, and you find more or less that implementation there, right? So it must have learned it from someplace. I'm not saying necessarily from myself. Maybe some others have written about it, like I did back in the days. But when I published that stuff, there weren't that many sources around who took up these topics, right?
I wonder if it has access to publicly available books, because when I ask about articles in journals, it tells me that it doesn't have access to the.
You're sure, because they have paywalls,
yeah.
right?
So it might have been like, if your book is available online, and then Mrs. Kelly got that.
Yeah, they must have some, how shall I say, they must have some partnerships or licensing agreements with publishers. I don't know, for example, I'm not aware of I could ask the people I know, but they are maybe not high level enough that, for example, O'Reilly, I said, you can train it on the learning platform of O'Reilly, where there is everything from O'Reilly, from Wiley, from whatever, right? There are, I don't know how many thousand books are there in machine readable form, for example. Because my experience is exactly, so for some books, they know like everything. You don't need to have a PDF in order to get the 20 key takeaways, blah, blah, blah. They know everything. The machine, right? The models. And other books, they say, well, I have no information about that book. So there must have been something. It has been trained on many books, but I don't know where the limits are or where it starts and where it ended, right? So here the final thing is just about giving a step-by-step explanation of how this algorithm is implemented there, right? So the final thing here is about financial data science, right? So I have two examples. These are data sets that we are going to work with afterwards. Here there's not that much code. The one data set, I have it locally, but I can change that. I have uploaded it as well. HTTPS certificate. It is in the gist. It's a complete repository. Certificate tpq.io. Takes a bit. I've created this actually this morning. So we have data up until yesterday in here, price data, right? For Apple, Microsoft, Amazon, maybe I show this up front. Here, prices, columns. So here, Apple, Microsoft, Amazon, Netflix, Meta, Google, Intel, AMD, Nvidia, General Electric, Goldman Sachs, Bank of America, JP Morgan, MS. I was expecting for Bank of America. I know that it's in there, but BAC is not, for me, a typical symbol. And here we get the data. That's just price data. That's nothing else, right? That's price data, adjusted close prices starting here 1st of July 2014 and here until last available. A typical prompt could be, what can you tell us about the data contained in this data set? Also provide appropriate statistical analysis and visualizations. So the other one is also on the server. It's about fundamentals, maybe a bit more interesting because price data is omnipresent, I would say. tpq.io. So this is fundamentals data for the same companies, as you have seen before, and we get here from the AOD historical data API, market cap in million, EBITDA, price earnings ratio, earnings share. You see it here, right? What we get. These are what is called in their data set the highlights. There's much more fundamental data related to every stock that they have in the API, but this is what they call high. And I would say like analysts, investors, portfolio managers, that's what they focus on indeed, right? Like dividend yield, earnings per share, etc. So these are the two data sets. But
what API were you grabbing this from?
sorry?
That's what API were you getting the data from?
This is called EOD historical data. I have it open here. I'm logged into my account. In the GitHub repo, when you're there,
The sources.
I have provided here slides and agenda. Link to the data provider used EOD historical data. You can do what I'm doing here with a free account. You just need the an API token. We come to that when we get into that part. For the time being, I provided the data sets here for you. On the server. Sorry?
Just downloaded them from your sources and then it finds them.
Yeah. It's also it's A in the Git, and I have it on the server hosted as well. Right. And with a free account, you have a couple of free API calls per day. But when we come to that, we can discuss that as well. So let me maybe close all of this, what we have covered. So ChatGPT, new chat. Now the other option here, advanced data analysis. And you see, not for everything, like just to highlight this, in the default case, right, what you see here with the Hoover effect, you can attach images and you can chat about images. But it says when you want to do this, questions, discussions about people, right? I don't know, when you would upload a picture here of Joe Biden or Donald Trump, it says, well, I won't answer anything or discuss with you about people, persons shown in a picture. But if you have, let's say, a drawing from a whiteboard or whatever from a meeting or whatnot, this is what it is, what this is supposed to. But I don't have an example here. Therefore, here changing to advanced data analysis, it changes to plus attach files. And now I can attach files. Let me go to the sources folder. Here in the sources folder, we have EUD prices. I want to get here started with the prices.
This is available only for the paid version.
That's for the paid version, yeah. I'm not sure, but I think that everything below default is for the paid version, and GPT-4 as well. So for the free tier, you get GPT-3, but these $20, that's like, oh my goodness. Rather cancel your Netflix subscription and
It's
get that
$20
one.
per month.
Huh?
How much it is?
20 US per month.
I pay for things that are more expensive and stupider.
Yeah. Therefore, for me, it's. Think back in the days when I was a young child, we had this huge encyclopedia in Germany. It's called Der Brockhaus, Die Brockhaus, right? This was like, I don't know, something like probably 50 kilograms total. As a kid, I liked to read it. And here you get basically the whole knowledge of humanity for 20 US per month. So that's, I think that's a good value proposition. So it has uploaded it. It calls it a spreadsheet. Okay. CSV is something like a spreadsheet, comma separated value files. But we can safely ignore that. The major thing is that it is able to read it, right, and knows what it is. So I've just copied this prompt here. What can you tell us? Blah, 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 and I simply copy this here. All right, let's start by loading the data set and performing an initial examination to understand its structure and content. The data set appears to contain end of day. It recognizes end of day stock prices for several companies. And where I was slow in identifying BAC as the symbol of Bank of America, right, here you get like the complete overview. It explains what every stock ticker is about. So check for missing values, provide summary statistics, visualize. So missing data, there's no missing values. I know this because I have created this data set, but usually you get some data set from whoever or from wherever, right? Summary statistics. So here's a summary, prices range from. Instead of this typical pandas data frame output, you get here words, right? Like in a style of a research report from a highly paid analyst. Visualization here to observe trends and patterns. I plot we observe a significant upward trend in Apple stock prices, especially post 2019. Microsoft stock also shows consistent upward trajectory. Amazon, considerable growth. Yeah, these are the tech stocks, right? And it's just for the 5. It's worth noting that most of these companies have shown significant growth.
It's just, I'm sorry to interrupt you. Like, how do you, so I got the ChatGPT-4. How do I make this advanced data thing active?
Yeah, when you go to new chat,
Uh-huh.
and then you click on the model.
Because it kind of shows me only browse with Bing and DALL-E. I upgraded to it. Is it like something that I need to show it?
Yeah, you might be going to here you references, settings, and beta, and you need to activate the beta features.
plugins? Translate and output.
Yeah.
Thank you.
Now you see where you.
All right, so thank you. Got it, yes.
So what I don't like about this plot is that it's not normalized, right? Provide the same plot this time with the starting values normalized to 1. Let's see if it understands it and does it.
One thing that I think I noticed, when people were talking about this particular feature of ChatGPT, that once you upload the data, it kind of, it has access to it forever. So you kind of, it's not yours anymore, right?
Yeah, so I wouldn't share anything
Yes, so
confidential.
it's not personal, like
Yeah,
confidential.
personal, confidential.
Yeah.
That's the problem, let's say, in particular in a corporate context. Think of a bank or a lawyer working with client data. That's why there is obviously also a big movement with regard to enterprise level solutions, which are closed door things, right? So here it's public data that I retrieve from some other
Yeah.
source, and right. So, but you see the result here. It does exactly what I'm asking it to do. Provide the same plot this time with the starting values normalized to 1. If you're interested in the code, you just click here and it shows it, right? The normalization, how it's been doing it, and the visualization. It also provides normalization. We can easily observe the relative growth. It's evident that Netflix and Amazon have experienced substantial growth relative to their starting prices. Also show Meta has grown steadily, but its relative growth is less pronounced when compared to the other companies, right? Now, provide a histogram of the log returns of Netflix. So to calculate, that's like your personal tutor, right? Or your
No, I call it my personal research assistant now. No, true, yeah. We don't have, PhD students here, so I'm calling ChatGPT my PhD student.
You see the log returns for sure not normally distributed, right? Clustered around 0, meaning high peak, higher than normal, right? Create another or let me say recreate the histogram, this time adding a normal CDF with the same mean and STD as the sample data from Netflix. One of a visualization that I like to do. Let's see if it gets it done. That's not a proof that, maybe it is already proof, however you want to call this, not a mathematical proof, maybe a visual proof that log returns are usually not. Oh, I said something about CDF. What I meant was the PDF. Right? The probability density function, not the cumulative distribution function. Now do the same, sorry, with the PDF. So this one, of course, if the human being is providing wrong input, the output can that's what I was looking for. So just illustrating right? The peak is much higher compared to a normal distribution. And we have obviously here fat tests. I don't know where this large drop here is coming from, the past, right? And so we can now go on and do analysis, getting visualizations, getting the Python code, right? It's amazing, in particular the code execution. It cannot execute everything, right? So, of course, the code execution here depends on the Python environment. So when you now want to do something which requires a very specific package or whatnot, right? Or I think I tried something with TensorFlow. I'm not sure. So I think it easily can generate TensorFlow code with the default model, but it cannot, as far as I recall, use TensorFlow code here in the advanced data analysis, because in the environment they don't provide TensorFlow. Right? Yeah, that was the one thing. Maybe now the just to conclude this whole part here, the fundamentals. EOD fundamentals. Again, it says it's a spreadsheet. Fine with me. My prompt, my sample prompt that I was suggesting, maybe I leave the grouping out and do this as a follow-up so that it first has, right? By loading the new data set and taking an initial look. So the data set seems to, the financial metrics name, right? Now we get the detailed explanations, at least of some of the metrics here. Missing values. So it has obviously a standard template of doing this, right? Let's first check for missing values. Let's see in there, right? Now it's going on, right? It transposes the matrix, the data frame, so that it can generate summary statistics. That's basically not necessary, right? With pandas, you can go your statistics across both axes in a data frame. But anyways, we just here are interested in the output. Next, let's visualize the market capitalization. Here it picks out 2. I don't know by what means, by what criteria it picks out the 2. And also, in and of itself, it restricts the analysis to 5, for a nicer visualization. Of course, you can say now, give me it for all or for 5 others of the data set. It will simply do what you say, but alone this, how shall I say, initiative that it shows is noteworthy from my point of view, right? So let me specify the grouping. Can you apply on because this is one of the examples that I have for later, apply unsupervised learning such as k-means to cluster the stocks, let's say into 4 groups. Interpret the results. Bit more specific then. Can you provide some grouping? Let's start with the pre-processing. Handling missing values. We know it's not there. It could know it as well because it has done the analysis. Normalize the data, are sensitive to scale. I think when I did this last year, this was one of the examples with regimes. I mentioned that as well. I mentioned scaling so often, and I'm still kind of like surprised that I forgot to do it with the option pricing example, but that's like not seeing the forest because of all the trees around you, right?
Give me some non-numeric entries.
Yeah, it's complaining about.
Let's fix it.
So now it does something. So we have 4 clusters, right? Here, Intel, AMD, GE, Bank of America, and Morgan Stanley, Netflix, Goldman Sachs. I don't know why. So relatively lower market capitalization, moderate EBITDA values. Here we go, right? This is fantastic. I love it. Okay.
That's awesome. I don't have to write any code.
I can say, well, Janet asked me to come and give a workshop. ChatGPT, can you take over? Here's the agenda,
You
right?
just sit back and
Yeah, that's
have
the.
that.
So cluster 0 and 1 are relatively similar in terms of metrics, but differ mainly in their growth projections relative to. I think this all makes financially sense, right? That's sometimes difficult to come up with interpretation. Cluster 2 is distinct due to
Your first cluster? I'm just comparing like what here I got.
the very first one. Yeah, this is what I was saying before. There's no guarantee that you get the same output
Yeah,
when you repeat stuff. A and B, when you do the same thing as I do, there's for sure also no guarantee that you get the same. But this is the one thing is with regard to some randomness from JetGPT, but the other thing is also random initialization of the clusters, for example.
Yeah.
So with the method used here, you can get different outputs from the outset, right? Yeah, and so we are now expert financial data scientists. Point is only that you need to know what you want and how to formulate, what to look for, right? But this is, let's say, what a portfolio manager would do and brief a quant researcher, an analyst to come up with whatever, right?
I think the important thing is to kind of, if you're teaching students, to teach them how to ask the correct questions.
Yeah. Of course, you need to have domain knowledge in order to navigate all of this, right? That's for me now. When somebody would ask me, "Can you?" I don't know. Just need to invent something. Do the same workshop AI in finance, or instead of AI in finance, do AI in biotech. I wouldn't even know what to ask, right? What protein synthesization and right? This is you still need it, right? And the problem, I don't know, there might be people that have high level knowledge, let's say experts from the field, no programming background. How could they go about something like this, right? To say, well, I have this data set, I have domain knowledge, but don't know anything about programming. If you don't know what clustering is, you cannot formulate a question about clustering, right? So I don't know how this will turn out in the future if people will be trained on a higher level, where you say, well, you don't need to know how to implement scikit-learn clustering, right? This is what a machine does, but you need to know what you can use clustering for, what the basic algorithm is all about, and here are 5 example prompts of how to do it. It's like when you jump on your car and say, this is how you program your navigational system in order to get from A to B. You don't need to know anything about general relativity, but it's pretty important, right? Because GPS doesn't work without theory of general relativity. Interpunction between 3 satellites, right? In that sense, I can imagine that's more like in the future, and that you get also, what they call fine-tuned models for a specific domain, for specific use cases that are simply more constrained, and you don't leave that much open, right? Here, with standard JetGPT, you can drift away from whatever, because JetGPT knows basically everything. You need to maybe be a bit more concise, but again, I cannot getting in preparation for this workshop. I did the examples. I'm like,
I mean, it still requires human brain
I'm flashed.
to figure out if it's doing what you're doing correctly, what you want asking it to do correctly, like, or if you know, which boils down to did you ask the right question? But you still have to apply brains. So I think, I don't think it replaces us from that perspective.
no, that's not what I'm talking about, but it replaces parts of us,
Yeah,
at least when we define ourselves as a person who has a job.
it's like a vacuum cleaner.
Yeah, sure. It's like with regard to the preparation of the workshop, where I was saying the disclaimer, when I'm shown now stuff following up on this, I don't pay attribution. This is like saying, well, or I'm not pretending that I came here by boat, right? Everybody knows I flew over the ocean, right? And the same for me is like ChatGPT. It's now there, right? You use it to accomplish things. I don't know if there is any value in not using it. Probably like, I don't know. Again, the exam situation is like the major one. How will exams look in the future? I mean, there's at least a setup where you have control, right? But with papers, other assignments, home assignments, even people, young people, not people, pupils, I must say, they can use that, right? To come up with like answers to the most simple ones. And I don't know I don't have a feeling for that. But as domain experts, let's put it that way, be it legal, be it medical, be it here, it's a wonderful thing, right? To have it available because it makes you much, much more efficient. Alone the search, I mean, it has been trained, for example, on Stack Overflow. How much time have I spent on Stack Overflow to figure something out? You have a question, then you have all these redundancies, and it was not correctly formulated. Maybe the problem that is in the Stack Overflow question is just like 80% overlapping with your question. Then you have like 19 answers which have been upvoted and downvoted, right? And here you go to Perplexity and ChatGPT and you get something that 9 out of 10 cases is directly usable and answers your very question and not something. I mean, I could of course post that on Stack Overflow as well, but I've never done so in my life. I was just a consumer, if you like, a passive user, right? Yeah, we don't need to overdo this here, but at least I want to get your feedback because I'm personally really interested in that, and against the background of higher education, let's say, maybe not that much against the background of a professional, having finished college, I don't know, 20 years ago, and is now amazed by the potential. But how do you see it? What does this all mean for higher education?
There's been a lot of discussion about that. I think for one thing, we need to, I mean, you've got to make sure the students get the domain knowledge, right? And so that's the hard part. Anyway, is giving them the domain knowledge because they don't get it necessarily, right? The first page one.
But do you see benefits or problems with using ChatGPT and other LLMs? So when I say ChatGPT, replace it by whatever jumps to mind in acquiring the domain knowledge. This is my first example, right? It helps you to dive deep into text, to summarize text, to ask questions about the text, to the text, so to say. You speak to the PDF, right?
Yeah, it's been really useful for synthesizing information, especially if you're getting it from a bunch of different sources. Like if you've got slides, a textbook, multiple papers you're looking at to try to understand what the topic is. It's really good at kind of, the more stuff you feed it and kind of ask it the same questions based off the different sources, you kind of start to get at least like a broad view of synthesized information on the material you're talking about. So it can speed that process up a lot if you were going to be doing that anyways. Like if that's kind of the way you were grabbing all the information.
But then the next question is, wouldn't it be beneficial for you yourself to do this synthesizing on your own? Isn't this a key part of the learning?
I think that's why it's helpful that it hallucinates. Actually, I found that very useful.
So you mean that are making sure that the quality is correct?
Yeah.
That's
I
your way now.
Exactly. It's part of the learning process, I think, to give it increasingly complex questions so that it eventually starts throwing errors and then you can try to figure out why. That's kind of how my brain works, so it's been very helpful in the learning process, figuring that out. Like, how far can I push an LLM until it kind of breaks the logic of what it's like? It doesn't really know how to put it in this particular way I'm wanting it. And then it can be, whether a programming challenge or kind of a logical challenge, like, okay, well, how do I correct it? What information is it lacking? What logic is it missing?
Yeah, this sounds to me like gamification of the whole process.
That's
right?
basically what I'm using it for. Exactly. That's more or less what it is.
But if we put it one level higher, we say, well, is this really helpful or not? That's what I can't answer. Of course, it's faster, right? When you say, my job is to synthesize the major, I don't know, hypotheses or insights from 10 papers. This makes it much more efficient, right? This part is replaced. But my question is, and I cannot answer, wasn't this always one of the major parts of learning, acquiring, and getting all of this, right?
I think it also depends on kind of how your learning structure works. For me, I work a lot better if I have kind of an in-road map to know where I'm going. And it can help with kind of, like you said, the mind mapping, structuring a layout of the subject at hand. And then from that contextual mind space, you can then dive back into the more in-depth stuff. And so it's more of a structural mechanism, I think, than even a direct teaching. It's kind of, I at least grab a lot of the indirect learning from it more than anything else.
Yeah, of course, there might be also individual preferences or personality traits or whatever you want to call it that play a role there. Yeah.
Well, I think it's still kind of out there to find out. You know, I'm personally finding that it's helpful for me research-wise. And honestly, you know, I have not seen a way of using it to replace learning. I don't think it can replace learning. If you think that it can, then it's some kind of way you're fooling yourself. But it can help you as long as you have the knowledge. So I don't know. I mean, if you look like back in time, like we started like back in the years by learning the theoretical things, and then we started applying them, right? And now we're deeply into the application, and it seems to me that now we have to kind of go back and kind of learn these basic theories, because now we have something that can do this application for us. But without this knowledge of the basic concepts, you know, like asking ChatGPT questions, as you're saying, like on area that I have no clue about, will give me some answer, but this is not knowledge for me. It's just like, oh, okay, you know, it's
like data and
I don't know what it is.
information gathering, right?
But to learn about it, you know, it's I have to go through some process.
I mean, as a student, this thing is amazing, right? I have to teach coding in my classes, part of the data analytics. I'm like, yeah, I can explain the code the way I think about this code, but you guys can just paste the code as well in ChatGPT and just tell it, explain to me another way how this works. So it's a TA, a free TA.
Yeah.
That's a
I agree on that. I agree.
So this is like this typical prompting, you act as a whatever, domain expert, tutor, father, or whatever, I don't know, right?
Yeah, no, I think students can
that's-
use it, you know, and like, you know, hey, you know, I'm learning about this, you know, give me some, like, summarize this topic, give me some questions to practice. I think that like what you're showing at first is like, it's really helpful.
Yeah, I must be, now that we discussed that and I'm asking the question, I noticed that I haven't used it to learn something really new for myself, right? So because I have this history and now I use it like, you know, like with all my background, but I would need to find a topic that interests me enough to try to learn something new by using it, right? And to see how does it work, do I understand it, right?
But the issue is, I mean, when you showed the BART code, the code that BART provided, right? I mean, if you didn't have the knowledge, you wouldn't know that it provided call option instead of put option related code. So, yeah, you're going to learn something, but is it the right
That's the danger, right? That's like everybody agrees on you will need the domain knowledge, or what Janet said, right? Teach the domain knowledge. And then the question is, can it help in acquiring that knowledge? Who makes sure that it's all correct, what it spits out, right?
I mean, I think you have to learn the basic background, because if you don't, and you have to do that by hand. Okay, you can use your calculator, or you can use a spreadsheet or whatever, but you have to know some of it innately. And I'm thinking about in accounting, my students, I'm having them do financial forecasting. And if they don't know that retained earnings is on the balance sheet and not on the income statement, then they aren't going to be able to do financial forecasting even if they get ChatGPT to do it for them. So that's where I'm coming from with the domain knowledge. They need to do the stupid working papers and all that stuff all the way through one time, once, so that they know it. And then if they know it, then they can use, so this may be for higher level learning, when you get that basic information in your head. That's just, that would be my take on it. Like, you can ask ChatGPT to take a first derivative of something, right? But if you've never done a first derivative, you don't really know what it's doing when it gives you the answer. It may be a correct answer, it may not be a correct answer, but if you don't know what it's doing, then I think it's a detriment. I don't think you can get that higher level learning if you don't know the basic stuff. So calculus, finance, accounting, probably anything.
No, unfortunately, kind of basic. I mean, if you think about it, like, I always try to, when I worked on Wall Street, like, when my boss would ask me to come up with some forecasting thing, and then I just think about it. You go to a doctor, and let's say they use ChatGPT and tell you, take these drugs, and let's say it's some kind, would you do that? Would you trust that to kind of completely, for some, let's say you got the flu, it's fine, right? You'll trust it. But let's say you have something much more complicated. Would you trust it? Or you want somebody who is kind of independent expert from ChatGPT to confirm that? I think that this is where from my point of view, the main issue is.
And if you've gotten all your knowledge from ChatGPT,
Yeah.
then you probably can't reason through.
Yeah, exactly. So
It's a difficult problem.
yeah. Would I trust it?
Yeah, I think that is an important thing, is to have, once you have kind of the set base of knowledge, one of the useful things of it is the kind of iterative exploratory process. It's, especially with any of the generative models, generating different versions of explaining the same thing, which I think definitely has an educational benefit to it, especially once you understand the topic. It's kind of like pushing your domain knowledge out towards the fringes to be like, oh, I've never seen it in that context, I've never seen it applied that way. And you can just, that's what it's good at, it's just iterating new examples.
But that takes.
And it doesn't get tired, right?
Yeah, right. Exactly.
Doing that takes discipline, and so if you're talking about a typical, now if you're an undergrad, I'm not talking about you because you're here. But if you talk about a typical undergrad, taking their first finance class or first accounting class, if they can, often, if they can cheat, they will. And so they're not getting the information, and so if this is enabling them to cheat, then they're not getting the information, and therefore they don't get to the point where they can ask those higher level questions that require, domain knowledge, and then that you can critically think about once you have the answer. So you have to have the tools to do the critical thinking to be able to, even if ChatGPT is 100% right, every time.
I don't know, far from.
Yeah. Even if it were, though, you'd still need to know enough about the answer you're getting.
Yeah, but I think everything here is driven, obviously. It's a group here from a certain domain, right? A certain background, certain context, but there are other fields where it's not like here. We have the luxury, and in particular when you're talking about a program, right? You can specifically decide, A, it's running or not. The very technical side of things. This doesn't guarantee that the result is correct of a pricing or what. But still, you can also, in this context, you still can say with your domain knowledge or some benchmark, the price, like I have shown, 4.42, 4.47. Yeah, that's a typical numerical difference, with your knowledge about Monte Carlo, right? This is a luxury, but that's, my background, and I immediately after my pre-diploma noticed that business administration, what I was studying, just for the reason because the job market was so wide open back then, 30 years ago, for business administration, for like the McKinseys in the world, they all looked for the MBAs and the Diplom-Kaufmanns in Germany. I changed to everything formal, mathematical, like operations research, microeconomics, But what I want to say is I needed to do subjects like marketing, human resources management, a bit of tax, etc. How do you want to measure there when it provides an output? Is this now 100% answer? Is it a 50%? It's a good one? It's a bad one? There's so many wishy-washy, right? Social sciences where there is no real, yeah, that's correct and that's not, right? That's like bad, good, nice, not nice. We can, almost every argument was, is it correct or not? And I argue now there are many other disciplines that are studied at universities where you cannot really say this is good or bad or correct or wrong. Right? Maybe there, for an exam question, it might be okay. There are 10 points for that question, right? Here, like 8 things are mentioned, full 10 points. But that's the subjective thing from the teacher, from the professor, right? But apart from that, I think this is much more difficult. Right? Even law. I mean, law has obviously some strict frameworks, but still within the framework, there's so much left and right and up and down that might be reasonable, let's say. But you cannot say, well, this option A, B, C, I don't know which one is the better one, right? So I see many, but I think it's also interesting to talk about and to discuss about these things. Also the legal side that we have touched upon in the beginning, right?
But even from the law side, right? I mean, it was like, what, 2 months ago when the lawyer in New York got in trouble because...
It came out that he got something from ChatGPT. But I think this is a pretty nice anecdote, but obviously these models will get so much better, in particular with the fine-tuning to law, with the fine-tuning to that, and here and there. Yeah, but nevertheless, it's a nice thing. You can do that stuff, but you shouldn't get caught by doing these things.
There's
Anyways.
also that guy that wasn't a lawyer, that won a bunch of cases. I heard about it on one of those late night talks. Yeah, that he won a bunch of cases, and but he wasn't actually a lawyer. And so of course they, busted him or whatever. But somebody, I think it was in New York.
And I feel like even the case with the lawyer that, basically, if you're talking about the one I'm thinking about, it's the one where he was more or less using it to do all of his drafts and briefs and arguments, and it was just creating fake citations for court cases that never happened. It is kind of like the college experience of somebody paying somebody else to write their paper and just not checking. And it's like, it's that same kind of mentality of exactly what you wouldn't want to use the tool for, which is just blatant cheating.
Yeah. I mean,
Going back to what Justin was saying before about the...
Like, best of luck to you. I mean, you're going to run into problems quickly with that kind of mindset.
It can only might be worse.
Yeah.
yeah, but 2 things. The one thing, when I was studying my business administration degree, I had many friends. One of my best friends even studied law, and they regularly invented references when they couldn't find anything.
No
Right?
way.
Sure. I mean, they got pretty good in like inventing names and like proper titles for papers and even books, right? Say, as da was pointing out that da, right?
Dane versus Studs.
Yeah, right, pretty much.
Yeah, in Germany we don't have case law. It's usually the single cases are usually irrelevant. It's more like, it's the law itself and the legal opinion about the law. Therefore, referencing is not about cases, right? You don't need to invent a case. You need to just say, well, this author has written about that paragraph of that law, A, B, C, D, E, right? That's the one thing. And the other one, cheating, our former, what was it called? Military Verteidigungsminister, right? The guy responsible in the government for the military. He cheated on his PhD thesis and it came out. So, yeah, this guy was like Karl Theodor zu Gutenberg. And he lost his PhD, but afterwards he wrote then a proper PhD. So I think in the meantime he got, the real PhD. And there were, like in Germany, we now have many, and there were a bunch of cases in the government, in the German government, where they had like ghostwriters and everything. They were like, without any reference, like having pages of text out of the Frankfurter Allgemeine Zeitung, etc. It was ridiculous, right? What you were pointing out. When you cheat, you should make sure that you cheat, like, intelligently, right? And not like, yeah.
Yeah, but the thing is, in order to be able to cheat intelligently, it's like you still have to know things because
Sure.
it's really easy to see
Sure.
cheating that is done without kind of thing.
Yeah, notorious liars must be very intelligent.
Yes,
You must recall
you
what
to
you
be
have
smart
lied
in
about.
order
Yeah.
to cheat smartly. That's what I'm trying
Yeah,
to say.
yeah.
It's not that easy to cheat, so you would not be caught cheating. That's what I'm trying to say.
Yeah, but there are many psychological studies really about liars. People who lie regularly. They need to keep up the web of lies and to keep it consistent, right? Vis-a-vis so many people. Like that's.
Sometimes it's easier just to kind of not cheat rather than blind cheat and not, be caught. You may need to put more effort into the second one.
into the proper way, like.
I'm just gonna learn this, and that's it. And it's like, I'm just gonna try and cheat, but then, oh gosh, like now I have to know how to do it correctly.
Interesting. Yeah. Yeah, maybe. I don't know if we have a set time, but given that we have started a bit later, I would love to do a bit more
Take a couple of minutes. And then we go.
before we then have maybe some lunch break or something. Yeah, just some basics to repeat. I think these are similar, same slides that I use regularly and also in the last workshop about learning itself. So far we have used AI, right, to do something, to generate things, to learn stuff, right? But for the remainder, right? Of the workshop, we want to implement that stuff ourselves, right? That's the major part here. And therefore, just a quick review of the methods that we are going to encounter. So that's my favorite generic example, right? In math, from an early age on, right? Latest in Germany, when you get to the gymnasium, you're dealing with functions. And you put in some numbers into a function and then you get some output, right? Statistics is the other way around. You have the input and the output, and then you try to figure out some function, right? So you're looking for functions in general. You can talk about relationships or whatever the certain context is. When physics, you may be a law, right? The function can have different names. Here in a very simple case, you would consider something like linear regression. Very simple thing where you have maybe a couple of sample data pairs and you try to find the linear function, the line through all your points. Actually, when you visualize it, that minimizes the mean squared error. Like A and B are your objects of choice here. So that's my very simplified view of statistics. So function generates data is math, and statistics is data generates function. And basically, most of machine and deep learning is exactly data generates the function, right? In supervised learning, you have your features, you have your labels, and then you try to come up with an appropriate representation, approximation, representation, however the wording is in the particular context, right? We are looking for relationships, for functions, etc., right? So here the schematic representation, function plus input gives output, statistics, input plus output gives function. Right? So here I try to keep it on a high level. In statistics, with regard to regression, we would call them independent variables and dependent variables. And then we have our regression function embodied usually by the regression parameters, right? So machine learning now, and my traditional example here is about trading and programming, right? When we think in terms of algorithmic trading or day trading or chart-based trading, you have maybe some rules, some chart formations, and then you implement the code for that and you apply market data to it and you get some output. Can be a buy signal, a sell signal, whatever. And so many other examples fit into this very simplistic high-level description. In machine learning, we wouldn't start with the rules and the code. We would have input, output, or the features and the labels in supervised learning, and we would end up with the rules themselves and the code. So when I was giving in the past talks about algo trading and machine learning applied to algo trading, many people were coming over after the talk, said, well, I have these 5 rules and patterns and whatever I trade. How can I teach the machine, the algorithm, about these patterns, right? Or how can I make the machine learn my patterns? And my standard answer was basically you should forget about your patterns, right? If there is something about the patterns or something similar to your patterns in the data, then the machine is supposed to learn it on its own, right? The machine shall come up with the rules, with the patterns that are promising to do whatever. Again, my canonical example is trading, but what you see here, what I'm talking about is, of course, transferable to so many other domains, obviously, even beyond the financial domain, right? So now the types of learning that we have. All these examples have been inspired by the classical supervised learning, but let's get started with unsupervised learning, for which I have then also the examples. These are algorithms that learn from a given sample data set of features only, yet just the input from the slides before. They are supposed to learn about the input data set, given, for example, some guiding parameters. Usually not like, I mean, it's nice with ChatGPT, you upload a data set and you say here and there, without providing any parameters or boundaries or frame for that. It has this obviously built in, right? You have seen it has this blueprint. Now I check for, not the number, for missing values. Now I do this, and this look kind of like similar, right? Going through this. Clustering algorithms, for example, fall into that category, and I've prompted ChatGPT before, right, to do the clustering, right? We have all these stocks now, do a cluster. I didn't even provide the features, right? It on itself has chosen a number of the available features and then the clustering. Financial context, such algorithms might cluster stocks, here we have it, in text form into certain groups, what we have accomplished before. Here, simple visualization. This has nothing to do with stocks, not even with financial data sets. These are clusters here visualized, generated in a random fashion. Scikit-learn has a number of such functions that create for different machine learning problems appropriate data sets. So that without needing any real world, maybe API, retrieve data set, you can get started implementing or illustrating the problems. That's, of course, for authors and teachers pretty convenient that you have always data sets available for free out of the box, so to say. Supervised learning, the standard case that we have discussed before. Algorithms that learn from given sample data sets, now consisting of both features input and labels output values. Right? Examples are ordinarily scarce regression and neural networks, for example, but there are so many others like support vector machines or tree-based algorithms, etc. pp. The purpose of supervised learning is to learn the relationship between input and output values. This is learning by example, if you like, right? This is like when you learn to play chess, you go through, let's say, historical chess games presented in a book and commented, right? You see, this was the board position, this was the move, and the move was motivated by the following considerations, etc. So learning by examples. When we come to reinforcement learning, this is more like, here is a machine against which you can play, and now try your best, try your luck, right? Playing against a machine and just getting feedback, this is good or bad, right? It's kind of interesting. Usually when people meet for the first time, there's always like this feeling out process and speaking here, asking questions, right? And there's so many, in particular, you see this with billionaires. They have their, communication manuals, right? Where they, when they get interviewed, they send their 3 pages. They say, well, don't ask questions about this, no cameras, no here, no there. So the interaction part basically is dropped, and examples are provided to learn a bit faster. So in finance, we might train, for example, an algorithm to predict whether potential data is credit worthy or not. One of the examples that I have brought with me this time around as well. So classifying credit scores, right? Or coming up with credit scores given a number of features describing the person. I think this is a data set that was from persons, from people, real people, not from other legal entities. Here, a very simple implementation where a supervised learning algorithm learns here, as you can see, the OR function, right? So that's function approximation, if you like, and in that very simple case, the approximation gives the perfect result, right? Python code, just with binary features as well as binary labels. So reinforcement learning, briefly mentioned before, so these algorithms learn from trial and error, and that's basically the closest to how we human beings or animals, pets are learning, right? You try something, you get feedback, and you do it again. When you learn a new sport, playing tennis, right? You try something, oh, the ball is in the net. That's feedback, right? And then you try to adjust maybe the angle or whatever, right? And or the force that you use for your next ball in order to get it above the net and into the field, right?
And then you get out and play pickleball.
Yeah, of course. That's like early. That's the early break here. So here an optimal action policy is updated according to what rewards and punishments they receive, right? Carrot and stick, maybe we can say here. Such algorithms are, for example, used for environments where actions need to be taken continuously and rewards are received immediately, such as in a computer game. Right, this is where it all started out with regard to reinforcement learning in its modern form as we now apply it, and similar to what we are going to implement, but on a relatively simple level, obviously, right? But these algorithms here, reinforcement learning, in combination with other algorithms like Monte Carlo tree search, for example, they were finally able to crack chess pretty quickly with 9 hours of learning only. Or the game of Go, which is more complex. So the final numbers that I recall from Alpha Zero, DeepMind, right, were 9 hours of self-playing for chess and 13 days of self-playing for Go to achieve higher level than any human being and a higher level than any other machine, any other algorithm. For example, here one game, Lunar Lander, as it's called, right? And this is really like you, not physically, of course, these agents learn via APIs, right? They choose an action via an API, they get via the API back the score or some other feedback, right? They update the policy, another action is taken, the reward, until here in this game it is the goal to land the lander, obviously without crashing, right, into a rock or whatever. So these are basically the 3 types of learning, and I want to go through with you through examples covering them and the focus, at least in that part, before we then get tomorrow into the other more language-oriented parts, etc., is on supervised learning. Here the summary. Unsupervised learning, we have just a bunch of features, and the machine shall come up with the rules and the code. So it's like when you hear it, neural networks, they write the code themselves. It's not really code as we have seen it with regard to Python code, but if you go on a little bit of a higher level, you can really interpret the neural networks, for example, as code. Supervised learning, input plus output, gives the rules of code, or reinforcement learning, you have these reiterated input, output, input, output, input, output, until we have the policy. Again, my example, this is also tomorrow, reinforcement learning. We have learning implemented for the dynamic hatching of an option. right? Where it learns by choosing a delta and then seeing the payoff of the replication portfolio, how much this deviates from the real option price, and so it tries to minimize this over time to get better and better. The environment there is described in the Plex codes model just by the parameters, right? So what is the time to majority? What is, volatility is the same throughout. The major input factor is the stock price, right? Which changes over time, and this drives primarily the delta, obviously, right? But of course, theta has also an impact there. So, some simple financial examples. We have seen the data set already, so JetGPT basically have solved the whole problem, but again, we now want to switch sides and want to implement the very thing on our own. The first is about the fundamentals data set, and the second one is about stock price prediction, which I want to code with you together live, and after that then do also a little exercise. So I can close all of them here. Let me also shut them down so that nothing is happening. Some simple examples, and here we find the code already. So the imports are all but special, I would say. Maybe I can increase. Is this better? Yeah, I think this works. I also can collapse that. So stock clustering. The data is from end of day historical data, and we have seen the data already. Let me replace this here because once it is on the server, but in particular when I know that I'm flying for longer times, I like to have my stuff locally for obvious reasons, right? To retrieve larger data sets when you're on the airplane. It's not really efficient if it works at all, right? Therefore, this was first referring to the local data set, but it's the very same now on one of our servers. We know this data set already. So Apple, Microsoft, and JetGPT, I think, did a great job in providing the real company names based on the simple interface. But again, alone the domain knowledge. Oh, this looks like a data set which provides for a couple of tickers, end of day prices. Here are the symbols with the companies, blah, blah, blah. Right, that's already something. Because we are finance people, we might expect that it knows that, but again, there are so many other things where we wouldn't have probably a clue what it is about, and I'm sure that JetGPT has, at least with a relatively high probability, it has a clue. So we have the data here, and what it has been doing before, for example, when it was calculating the higher level statistics is the transpose. This can easily be done here, so that we see now, for example, all the symbols as the indices and the previous indices here, the statistics as the column headers, right? So what do we want to do now? For the reasons of simplicity, and in particular to be able to visualize the results. I didn't ask for visualization before. Here I pick out quarterly revenue growth year over year and the return on equity as the two major statistics that I want to focus on. This is more or less arbitrarily, but I thought, well, here it's a good measure for the overall profitability, and that's like the growth story. But of course, we have more data. We could have picked others, but the major thing is here I want to have two, so that I can do a 2D visualization afterwards. So picking out the two, we now have this, much smaller, right? Data frame, 2 columns, pretty long column headers. Usually I don't like these, therefore I just go here with growth and return on equity. That should be good enough for us, short enough to have an easy read and less typing throughout. Just 14, of course, we just have 14 symbols here, fundamentals data It's usually not that or as large as price data. In particular, when we get into the tick data or intraday data, minute bars, etc., we usually have kind of larger data sets. Now, the clustering with the raw data. So raw data means here we go with the data directly as opposed to normalized data. You might recall what JetGPT was pointing out right here. So where did it do it? Was like before data here, data pre-processing, handle missing values. We know already there are no missing values, simple data set. We see it basically immediately. No need to look for not a number values because we have it all inside. Normalize the data since clustering algorithms like k-means are sensitive to scale. So that's therefore I distinguish between raw data and the normalized data. So I'm basically now doing, and I haven't prepared for that, but I thought since we are doing it, we can first let GPT do the trick here. So I import k-means, and here I decide for 3 clusters. Of course, I can set this differently. I fit the data. You see that's pretty simple, and we have, generally speaking, for these standard algorithms with scikit-learn, we have this 3-step procedure. Here the first step, model instantiation. The second step being model fitting. And the third step being prediction. Right. And this holds true for, I wouldn't say for all, I don't have everything now in front of my inner eye, but for all supervised learning algorithm, unsupervised ones, we typically see this 3-step procedure. So executing this again, I can now generate my predictions. And at first sight, we see that it has just one company in group 1, or cluster 1, right? It has a ton in 0, so in the first one, and just 1 in 2. Here, the scatter plot, I said the major reason for the 2 only is to have a visualization. So here I was playing around in preparation quite a bit. I'm not a big fan of this particular scale, but with the data 0, 1, 2, whatever, many of the color maps, they have around 0 then something like white or like bright gray or whatever, and you couldn't see it. Therefore, I've chosen this green, red, blue one, which is throughout pretty easy to visualize. So, or to see, to recognize in the picture. So here, well, it's not 2, right? Given the 2 that we have chosen, we have here a cluster and here, and now that we see this visualized, I think we might have come up with something similar, right? Interpretation, I have asked JetGPT for the interpretation here. I think it's relatively easy and clear, right? Low growth and low profitability. All the banks probably are in that part, right? And then we have here a high growth company, and here we have a highly profitable company with low growth. Right? So these are the 2 dimensions. And therefore, sometimes these clustering exercises, they seem pretty simplistic, simply because in 2D, it's like what we would do, like a cross through it or whatever, 4 quadrants, and then we are done. Of course, these algorithms are not constrained to 2 dimensions, but again, otherwise it's difficult to visualize. Not impossible, but difficult, and I will show you also a 3rd dimension in this context. So normalized data, now I normalize it to Gaussian normalization. I like to call it Gaussian normalization, maybe because Gauss was a German guy, or Z-score normalization. Subtracting the mean from the data and dividing by the standard deviation. So now, when we have a look at the data, that's what I always consider like a bit of a drawback. We are having a hard time really interpreting it, right? There's a return on equity, we would expect something like plus 10%, minus 5%, right? Here we now see 3.27, da, da, da. But for the machine, it doesn't matter. We could always go back to the original scale if this would be something of interest, right? But here in that context, it just uses the normalized data in order to come up with the groups, and then how we visualize that is some other question, right? So normalizing, here k-means, I show now a bunch of other parameters here. The data fitting is done obviously now with the normalized data. That's the very goal here. The prediction is done based on the normalized data. And here you see in this example I've chosen 5, for example. And I can now do the scatter plot here, and it's coming up now with other groups. And I said, and I show you this because I was pointing this out, I can also do the with the original data. No need to plot this necessarily into the 2D chart with the normalized data. I can get the same result with the real growth and equity data. In that sense, it's just means to an end that we do the normalization. It's just a way of coming up with the clusters, and then I use the result in the original space. Done in mathematics all the time, finance, I would say, mathematical finance all the time. For example, with Fourier transforms or whatever, you go from one space into another and then back again once you have achieved the result. So here we now see 5 clusters. We have the 2 outliers. They are extreme. We can do whatever we want. Just with regard to these 2 measures, they are extreme ones. And here it's now, since I have initialized 5, it's giving me the 3 of them. I could have done 5, 6. You can play around with it. It's a pretty small data set, just taking 2 features. It's more about how you do it in general, to visualize it, and then maybe later on to apply it to a, let's say, proper case based on larger data sets and a larger number of features. So most of them pretty close, and here 2 of them, here they are 5, right? 5 more, 1, 1 in terms of the outliers. Now let's add a third feature to it. I add here dividend yield to it. So that's the dividend given against the share price, right? And the data now obviously have 3 columns, 1 column more than before. The rest is as it was before. We get here now a column with pretty smallish numbers. Even some of them, if not many, right here in particular the tech stocks have no dividend yield, but the banks, for example, they all have some reasonable or let's say, given the rest here, significant yield. When you see so many with 0, 0, 0, right? And then you have somebody paying you 3.7, 3.6, 2.9, 4.7. That's non-negligible, we can also say, right? And here we see the growth here for NVIDIA. That's like one of the outliers from before. Again, the renaming so that we have a little bit of an easier time. 4 clusters. I had 3, I had 5, now I have 4. Do the data fit on the original data set? Now, I think we have 3 dimensions, 3 features. I can still do the plotting, so that's now the limit of what we can do. We have 3 dimensions plus the color as basically the output. And we see this now in 3D here. 4, did I do 4? Yes, 4 it was, right? 4 clusters, yeah. At least on my screen, I had this when I did the preparation. Some of these blue dots look darker, others look lighter, I don't know. This one for me looks lighter than that one. I would say that's a different blue than that one. But I checked it a couple of times. It's supposed to be the same. I don't know. Here we have the blue ones, the green ones, and these two outliers. Also in that space, right? Because they have simply one feature that is extreme. If you want to see this differently, you can change a ton of things here, like the elevation 25. Now we are looking more from above, or go to 45. Right, this is now moving it towards us. Or here going to 0 degree usually is not the best way, right? If we would use, for example, cufflinks with Plotly, you could do this interactively. But given that you need proper configuration of Jupyter Lab, etc., or Jupyter Notebook, whatever you use, I skip that part. But it's nice sometimes when you navigate, you can zoom through that. You get over all the access, you can move that. Here you have at least right? You have the all the options. From that point of view, it looks again different. What was my original one? I don't recall. 25? No?
I think it was 15 and minus 30.
Ah, minus 30. Okay. So I leave it as it was in the original one. I think we see all the colors kind of nicely. So that's with the raw data as before. Here now, I don't need to repeat this. Yeah, of course I need to repeat it because I have a new data set with 3 now, right? This is the normalized data. And of course, with normalization, even for quantities where from a mathematical, economic point of view or standpoint, or from the formula itself, we cannot expect negative values. Normalization will give us, for many such quantities, simply negative values. That's a consequence, natural consequence of normalization. Here, 3 clusters. And let me, here I use the non-normalized, and then I use the C. Was just checking what I did before. And it looks kind of similar. The 1 here was added now to that class. Maybe let's do 5 here as well, as I had before, right? And now we get here the nice, the 2 outliers for themselves, these 2, these and these. And you see now with this algorithm we can go to 17 dimensions, which we can never visualize. We only could do some dimensionality reduction with PCA or whatnot. But here we can do the visualization and you see the clustering. Again, with these clusters, we just have 40 names. If you would have 500 constituents of the S&P 500, we would probably see now balls in 3D space, right, where they compare. And all this obviously is driven by the parameters, by the features that I have chosen, right, by the metrics, the financial metrics from the table that I have chosen. Not for any investment decision to be made, rather technical illustration here in this context. Yeah, the next part will take a little bit longer, therefore I might, or we could consider having a break now.
Yes, it's already almost 1, so we're quite hungry.
Some lunch break. How long, Janet?
How long do you want to, when do you want to come back?
I don't know.
I mean, I put 4:30 on the, invitation I sent out without thinking that it was going to be a specific time. So, because I know people get in here and we're going in different directions, and sometimes you need to slow down, sometimes you speed up. So it's kind of want to leave that to you. I think if you guys want to go to lunch, other than eating my snacky things up here, those of you is everyone a student here? Mm-hmm. So you guys already know, you're already familiar with where there is to eat around here? Except for you? You're going with Vance? Yeah. Okay. Yeah, so maybe an hour and 15, maybe come back at 2? Does that work?
Sorry?
Come back at 2?
Isn't it too much?
It's 12:47,
Oh,
so it's an hour and 15.
Let's take
Well, let's say 1 hour.
Okay, an hour.
1 hour
So
should be
1 hour.
plenty, right?
Come back about 1:45. I was just giving people a chance if they want to go off campus, but we'll worry about that tomorrow.
Yeah, so let's do 1 hour. Oh, not for that one.
I never get applause for my classes.
That's not like.